Hey folks, welcome. Just want to give you a quick walkthrough of what's going on with runZero 4.9, exposure management for OT. So with this release, we really focused on two real areas. The first one is operational technology. We spent a lot of time building out great device classifications, function classifications. These cover all sorts of verticals from building management, energy, manufacturing, you name it. Part of this was also building out extensive protocol support for not just discovery of immediate devices, but actually enumerating backplanes and going pretty deep into the protocols. This is for Ethernet IP, SIB, KNXNet, VACnet, Modbus, and then we also added a few dozen new UDP discovery probes to go with it. As part of that, we now enumerate devices that are behind the backplane. So for example, if you've got a BACnet controller that's like a thermostat, we can query that, but then also enumerate all the other devices on the same bus as the back of it, which could include, more sensitive or more serious systems like fire, safety, and so on. We did a little bit of work too to identify internet exposed systems, and we'll kind of demo that here in a second. And that kind of led to the product work that made its way into this release. And of course, like any other work we do, there's lots of fingerprints, lots of bone coverage as part of it. The next section of work that we focused on for this release is just kind of upgrades across the board. There's now dark mode, light mode, and classic themes. There's now a world map that's both 2D and 3D for geolocated assets based on either egress IP or based on public IPs that they have. And then we put a lot of time into our new network maps. These are designed to replace the current layer 2, layer 3 reports. There's a new topology tracking backend that's a lot more performant. We do really cool segmentation analysis and tracing. And it scales up to about 200,000 assets at a time right now, and hopefully more soon. All these maps let you search, share, and export, and they make it very easy to track things like your OT exposure. Great. So we're going to walk through a couple demos of runZero 4.9. Here's what a network map looks like for a fairly small organization. This is a organization that has a normal office network. They've got some factory networks as well. So you can see that there's a BACnet gateway for building management. There's a Modbus gateway, various Modbus devices hanging off here. And there are also some plain old Ethernet switches that we've enumerated down here as well. And in this scenario, what we've done is we've set the source to be the public internet. So right-clicked and set that to be the source. We then picked a target system, the 10.66.0.30 device that we want to be the target. And now we're going to ask it to trace the path between it. So you can see that we're able to identify different routes between the internet to the system. And the device that is the target here, 10.60.0.30, is actually in multiple networks at a time. It's actually in this network and this network. So one of the reasons why it shows it like this is because we want you to be very aware that if someone's able to get to this particular device, they actually are able to get to this other network as well because the device will be multi-honed. And you can see that the primary path here is the one with the kind of like diamonds following it that's well highlighted. There's also many alternate paths. So just getting rid of, let's say, the first choke point, this open sense firewall, or even the SportyGet network, these were not be enough to prevent that access. You'd actually have to go a little further down and realize, hey, there's actually a network security scanner that's multi-honed that's allowing you to go from one network to another. Or in this case, a Windows system with two IPs that's actually bridging network. Or here, a Synology NAS device that's also bridging two networks together. That's basically becoming a path between the networks. So the tracing works pretty neat. You can actually disable the source or the target and actually look at inbound and outbound tracing instead. So we can say, look at all the inbound traffic going to this environment, and you can kind of see how packets would flow into it. In this case, we're going to go do the same thing in this team, but for outbound. So what's the outbound traffic look like for the internet itself going into the environment? So this will actually animate kind of all the different paths coming into the environment from the internet to all the systems. So a cool thing about this too is you can do a search. So we can search for something like, we'll pick OT device, for example. This is category OT. This highlights all the OT devices. We'll then pick a target device, this BACnet device, add that to the target, and then go ahead and trace the path to it. And you've got a really clear list of what you need to do to mitigate it, which are look at these choke points and filter it, and then details on the device as well. And of course, you can go look at the device in the network inventory and runZero as well, or just pop back to where it was. If you need to be able to share this view that you're looking at right now with a colleague, you go under the link dialog and click copy link with current view. And this will give you the exact zoomed in view of this network for whoever you share it with, which is great. You can also export the whole view as a graphic. You can export the UI as a graph database of various sorts, GraphML, GML for Gephi or Cytoscape, or just Visio as well if you want to load it in Visio. And yeah, the left side card over here has a few different options you can play with. You've got some kind of pre-canned queries like high risk, end of life, servers, IoT devices, cameras, etc. And in this case, you can see the cameras are all clustered down here in this IoT network, which is great. If we zoom a little bit, we can show not only do we identify all the cameras, but we're actually able to classify the subnet itself. We're able to say that this subnet must be an IoT subnet because it's full of cameras. Similarly, if we go look at OT instead, we'll look at OT and then we'll zoom out a little bit and we'll go find these OT subnets. And you can see these devices are being classified as OT as well. Backnet gateways are obviously already OT, so we're really only setting classification for the IP subnet here. And you can see that the subnet is very much OT based on the devices that are within it. You can also look for devices that don't match the ones around them. So we've got a couple ways to do that. You can do outliers. So outliers just show you as many weird devices as you can. So whatever doesn't really look like it, whatever the kind of rarest devices look like in the organization, the outlier rank greater than 1, you can narrow that down to 2 here as well and really limit it to smaller ones. In this case, there's no outlier ranks greater than 2. So in addition to outliers, which kind of show you how weird the device is relative to its neighbors, we also have misplaced. So misplaced are devices that are classified as IoT or OT, that may exist in the wrong environment. So here's the stuff that we looked at a moment ago with cameras. If we zoom in a little bit, we can see that there's actually some devices here that are not cameras in the network. There's a security console, there's another lab scanner, there's a Debian server. So we're basically flagging the fact that even though this device is primarily IoT systems, we did find devices that are not IoT in it. This works for both OT and IoT and IT. So if it's an IT network and we see an OT device, we'll flag that be misplaced, and then vice versa. So if you're trying to figure out where your wireless networks are, you can use the endpoints query. Typically, this will show anything with a mobile phone or a desktop or whatnot, and those tend to be wireless devices. You get a really clear sense of where a wireless network may be in the environment just by doing a search for endpoints. So there's a ton of functionality here. You can go really deep with this stuff. We allow you to filter every single hop. And so you can say the first hop will be port 22, but I want to exclude Windows machines. You can basically set the criteria for each hop of the trace, including different types of filtering. The search query at the top here is helpful as well. It'll give you kind of counts for anything. So you type in type, colon, it'll give you a list of all the different types it's found in the environment, at least the top 10. So if you want to find all your BMCs, click BMC. Here's all the different super micros, things like that. And there's a few ways to lay this out. The normal view of this is basically a rectangle. It would kind of go top down based on internet exposure. But you can also lay it out as a Hilbert grid instead. And it depends a little bit based on what you're looking at. But in this case, we're already looking at it as a rectangle now, so kind of long and narrow. But we can also reorganize that as a square layout as well. And there's a couple themes. So if you want to pick different colors, you want to take some screenshots, lots of ways you can basically restyle it. But yeah, that's mostly it for the network graph. And you're actually able to swap which network you're looking at on the fly just by using the drop-down up here versus having to go back to the main console and go back out. So in addition to the 2-dimensional network graph here, we also have a 3-dimensional graph, which is kind of fun. So if we click on 3D from the map, you'll see that we actually have a kind of 3D diagram of all the different networks here. This one's a fairly small network. So the kind of small trees, if you will, these are actually the backnet gateways, Modbus gateways, things like that. The internet here, these are devices that are connected directly to the internet to see mapped. We'll go ahead and clear the search query so we can see all the different nodes. There you go. So in this case, you can see that there's a lot of different devices. They're all fairly well clustered. We break them up by subnet, and the subnets are actually located at the bottom of the graph. And then as you get to the top of the graph is based on the risk of the asset. So you have a high-risk device, for example, it'll be higher in elevation than the devices below it. So you kind of, at a glance, get a sense for how insecure are the devices, how are they structured. And of course, you can do filtering here too. So you want to say, I just want to see just my OT assets. Click on OT, we break that down. Same thing with just my cameras, et cetera. We find our camera cluster over here. So this graph also allows you to download images. You can also share the map with your colleagues by sharing a link to the direct view you're in. And you can also swap to a rectangular layout here. So if you want to see the network a little in a different form, you can kind of lay it out that way as well. You can also turn off layer 2 links, turn off layer 3 links, and kind of filter it how you like. So there's lots of different ways you can look at different levels of the environment altogether. And that's kind of key. We want to be able to show you the layer 2 and the layer 3 combined. So network graphs are helpful for small environments. They give you a quick sense of how things are laid out, but they're incredibly useful for really large environments. So in this case, this is a whole bunch of internet-facing devices. So that's why it's so much red here. This is using the square Hilbert layout. If we zoom into it, you can see that there's quite a lot of detail. In this case, we are identifying entire subnets of systems. So, zooming all the way in here, you can see that we've got a lot of devices hanging out this network. This subnet is connected to all kinds of stuff. And here's actually a backnet gateway and then different backnet devices hanging out these networks as well. So we can set the backnet gateway device to be a target. We can then basically pick the internet just like usual and set that to be a source. So here's our internet node. And then you can do path tracing as well. And we'll basically, in this case, there's no direct path, but oftentimes you'll see a direct path from A to B through here. In addition to the normal network cards, we've also added an OT risk card. This is still being cleaned up a little bit, but you can say like how many ICS devices have public IPs. Quite a few here because it was a scan of OT. How many systems are operator UIs, like an HMI or panel? Quite a lot of those. How many of these devices are using clear text management ports? Things like Telnet or SB version 1 or 2. Again, lots of those. And then OT devices are end of life. Those pop out here as well. And then, of course, looking for pivot points, systems that let you go from one network to another. And, of course, remote management. So any system with a RDP, SH, things like that open. And you can see up here, it's actually writing out the query. So if you want to tweak the query, you can. So the 3D map for this really large environment is a little bit busy. But you get a sense for each of these clusters down here is a OT protocol gateway. And if we turn off layer 3 real quick, and then we focus on just OT devices, you get kind of a clearer view of like all these different individual islands of OT networks that are accessible through protocol gateways. In this case, we're looking at about 100,000 devices at a time. But yeah, it's kind of a different way to kind of view the network. Of course, there's also the world map. So if you want to be able to zoom into a particular asset and location, you can do that. You can also do a search based on a particular location. So we can search for Houston, for example. Probably not Houston, Texas. We can zoom into that. And as we kind of go find the asset, we can then get a list of all the devices that we see. And then we can also do a search to find everything that's near that device. So what's within 50 miles of this particular asset? This will take you to a geographic query inside the product. And from here, you can see a list of whatever's close to it. So we also have a 3D version of the world map, which is kind of fun. So you can zoom in on stuff. You can animate the globe. You can kind of play around and zoom in and stuff like that. So it's a good way to kind of get a sense for like how distributed are your employees, your systems. Is someone on vacation in South Africa, et cetera? Lots of fun stuff. And of course, you can also download, export, et cetera, from here. So that's about the summary for most of the runZero 4.9 stuff. There's a lot of other stuff kind of behind the scenes that we're going to go into later. But generally, that's basically it. It's a lot of new OT protocols, a lot of new OT capabilities, such as remote gateway enumeration, as well as some really cool tools for doing segmentation analysis and finding cases where segmentation is not working correctly. And of course, all the new maps. So if you want to play with it right away, if you go into the asset information and you click on manage, you'll see that there's view on network map and view on world map. These will be updated soon to be much more easier to find. These are just here for preview mode. But again, clicking on one of these guys will actually not just take you to the world map or the network map, but it'll actually zoom in on that particular asset once you get there.